Welcome to lesson 14 of C programming language. In this video, we will look at operator associativity and precedence as applicable to the C programming language. First of all, what is the plan? First, we'll look at in general what do we mean by operator associativity. Then, what is operator precedence? Then associativity and precedence table. And after this, some example expressions and statements which demonstrate the correct knowledge of associativity and precedence. Then we'll see a small working program. Now, as far as operator associativity is concerned, you can look at this picture. It briefly explains the associativity, meaning of associativity. Every operator has an associativity. It is something like a tug of war. So there is a pointer, and whosoever is successful in pulling the pointer to himself or herself beyond certain point is supposed to win. So here, suppose this is an operator, and if this right side guy wins, it means this operator goes with him. Okay, so an operator that binds first to the right side operand is known to be right associative, or sometimes we call it this operator is from right to left associative. So an operator can be either left associative, or it can also be referred to as left to right associative, or right associative, or right to left associative. And this associativity establishes the order in which the operators of the same precedence will be evaluated in an expression. Now, operator precedence, what does it do? It is nothing but the priority assigned to an operator when it comes to evaluating an expression. So if you have an expression and if you have more than one operator, then which operator would be evaluated first? That is nothing but the priority of the operators. For example, in case of all of us know A plus B multiplied by C, B multiplied by C would be evaluated first, then the result would be added to A, because we know that multiplication has a higher precedence than addition operator. If you recall from your school days, BODMAS rule, bracket, off, then division, multiplication, addition, subtraction, for these common operators. But here in computer programming languages, multiplication and division, they have the same precedence. Okay, so BODMAS rule does not apply always directly in the computer programming languages. Now we can understand the precedence with the example of a precedence in order of precedence in Bharat or India. In any government event or official event, President of India has the highest priority or the highest precedence. One. Second is Vice President. Third one is Prime Minister. Then followed by governors of states. Then former presidents, then deputy prime minister if that person exists, because it is not a constitutional post. In official notification, it is 5A, and followed by the Chief Justice of India and Speaker of Lok Sabha. In official notification, it is 6. So Chief Justice of India and Speaker of Lok Sabha both have the same precedence. Now let us see the associativity and precedence of various operators. So here on the leftmost side, I have precedence number 1, highest precedence. This is the pair of parentheses. Here it is used as a function call. Then the square bracket or array index. Array we will study in some other video. This is structure pointer. This symbol is made up of a minus symbol, that is dash or hyphen, and greater than symbol immediately after it. So there is no space between these two symbols. This is referred to as structure pointer, and the dot. This is used to access the elements of a structure. Okay. So all these operators 1, 2, 3, 4, these have the highest precedence, that is 1, and all of them are left to right associative. Similarly, size of is an operator. We will discuss this in some other video. Then type, it is used in typecasting, and then plus plus minus minus. Now here you will find then in a number of social media places like internet or some e-learning sites, you will find that they mention post increment and decrement operators to have a higher precedence than pre-increment and pre-decrement operators. I am referring to edition 2 of the book NCC Programming by Kernighan Ritchie. There they clearly mention these operators to have same precedence. Might be the later compilers following the latest standard may have the different precedence for these pre and post increment decrement operators. So one has to be very careful. Okay, I did not access the latest C standard. Then unary plus and minus, bitwise logical not and bitwise not. Then dereference operator and address off. These we will study in more details in some other video. Then these are the normal binary operators. They have the third precedence number 3, third in the precedence hierarchy. Then these are the addition subtraction, and these are the bitwise shift left, shift right, all of you know. So precedence number 2, all operators have the same associativity, that is right to left. Then the associativity and precedence continued. So here I have grouped them like this: less than equal to, greater than equal to. These 4 have the same precedence number 6, and they have the associativity left to right. Most of the operators have their associativity left to right. Then these are the operators. You will find these precedences in number of URLs. This is the ternary operator. We will study separately. These 11, perhaps they are 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These 11 operators, they are all right to left. Okay. And these operators we have already seen in some previous video: assign, add assign, subtract assign. So all assignment operators have very low precedence, that too 14, and they are all right to left. Then the comma operator, it has the least precedence, 15, and it is separated like int I comma j. Here it is separating these two variables at the same time. They are it is also left to right. Now some example expressions and statements. So remember, here it is a plus b plus c, binary operator, addition operator. So which of these two would be evaluated first? These two have the same precedence and they are left associative. So a plus b would be evaluated first, and then the result would be added to c, or c would be added to a plus b. So this plus symbol or operator between a and b would be evaluated first. But the problem is the standard does not define the order in which the left and right operands of this plus operator would be evaluated. It means if a and b both are expressions themselves, so standard is silent about whether a would be evaluated first, then b, or b would be evaluated first followed by the evaluation of a. So between these two they have the same precedence, so left one would be evaluated first, but two operands of this plus operator, which one of the two would be evaluated first? So one has to be very careful, because it is compiler dependent and the results may be different on different compilers. Using different compilers, the results, you may get the different results. Though there is no problem, the result is not going to change. A plus b is same as b plus a, we know. But the problem becomes severe when any variable or expression which is used in A is actually modifying the variable or value of variable or expression which is there in B, or vice versa. So if any of the two operands, they are modifying a variable or identifier or an expression, sub expression of the other operand, then the results may be undefined. For example, in case of second example expression, this is the expression right hand side. So this is plus, you have post increment also and pre increment also, and suppose the value of a is something, you can convince yourself that this would be the result. But we know that I plus plus and plus plus I, they have higher precedence than addition. But I plus plus would be evaluated first or plus plus I, because once you evaluate this, it is going to affect this I also. If you evaluate this first, then it is going to affect this, and ultimately it is going to affect this. Okay, so result is not guaranteed. It is compiler dependent. So never use such statements. You use parenthesis properly and split the single statement into multiple statements so that the evaluation is clear. The third, in case of printf, similarly plus plus n, and suppose you have written some function f of 3 star n 3 multiplied by n comma 1. So here the value of n is being modified here. So since function call is right associative, so don't think that this will be evaluated first, because here you are modifying its value. So to force a particular order, you should bring this statement before this printf and then increment it. Otherwise, it is always going to give different results across different compilers. Now, one example here, you can see what order does f1 star f2 divided by f3. Logically, it can be computed like this: f1 star f2 divided by f3. No problem, because multiplication, division, they have same precedence, they are left associative. So first here multiplication will be applied, so it will calculate f1 multiplied by f2, then the result will be divided by f3. No problem. Logically it is same as this. So f1 divided by f3 multiplied by f2. But remember, depending on the data, the results would differ. Now let us see some small working program I have already written. On the right hand side, this is the source code. Let me execute it. Now you can see here, I have declared three variables f1, f2, f3 of type long double. f1 is 1.3 in scientific notation, 1.3 multiplied by 10 to the power 28. f2 is 22.0 and f3 is 7.0. If you recall from my previous video, that 22 divided by 7 used to compute value of pi up to 2 places after decimal point. Now here this printf prints value of f1. Now you can see here it is not printing in scientific notation, it is fixed notation. So now you can see here I have assigned 1.3, but actually it is being stored like this. Okay, now f2 is printed as it is, f3 is printed as it is. Now print f1 multiplied by f2. So this is this value, f1 by multiplied by f2. Now f1 divided by f3. Okay, f1 divided by f3 is this one. Now you can see logically these two expressions are identical, but now you can see here the values are up to this point they are same, but after this they are different, isn't it? The same logical expression, but depending on the data, both expressions, both forms of the same expression are giving the different values because of this order of precedence. I am multiplying first, so whatever is the floating point number, its representation is of course not 100% correct, I mean 100% accurate. So it is represented like this, and here the results are different. Now let us have another example. Int x. Now it appears that 5 bitwise shift left by 1 bit position, then whatever is the result multiplied by 3. So what should be the value? 5 shifted towards left hand side by 1, so it is 10 multiplied by 3, 30. Value should be 30, but here it is printing 40. Why? Because intentionally I have written it as this operator would be applied first. No, this is binary operator multiplication symbol and this is bitwise shift left. So multiplication symbol has higher precedence than the bitwise shift left. So though it appears that bitwise shift left operator would be applied first, actually 1 multiplied by 3 would be evaluated first. It has higher precedence, so result would be 3, and then 5 would be shifted towards left by 3 bit positions. Okay, so shift by 1 it is 10, shift by another one 20, shift by another once more it is 40. So it is printing 40. Now this is the ambiguous statement, I should say. X plus 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 x. It would be parsed as x plus 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 x. But you know, as I have told you just now, that which of the two operands of this plus symbol, binary addition symbol, would be evaluated. So you may convince yourself that the result would be 81 or so, but it is not guaranteed. Across different compilers, the values may be different. Same thing here. You can write x plus 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 x or x plus x. Again, it is modifying. So the same identifier is getting involved in both operands of plus symbol. So here also it is not guaranteed. Under your compiler, you can convince yourself that every time it is giving the same value, no problem. But you cannot guarantee, you cannot ensure that the same lines of code would give you the same result under other operating system with different compiler, or the same operating system with different compiler. So here also I want to enforce the order, but what is happening? This would be evaluated first, followed by whether this or this. So you should use these operators intelligently, followed by same thing, whether this plus plus x would be evaluated first or x plus plus. Now this is more interesting. Here I have declared 4 integers. Int is of 4 bytes under my operating system, which is Ubuntu 22.04 LTS, and I am using GCC under that default GCC which comes along with Ubuntu 22.04. I have initialized S2 with 5 lakhs, okay, which is less than this number. You can refer to my video number 69, 8 minutes 3 seconds in English, and video number 70, 7 minutes 14 seconds in English. There I have given mentioned there that 4 byte integer, this is the maximum positive integer which can be represented accurately. So you should not, the value of the integer should not go beyond this. So here it is well less than that. S3 is 5000 and S4 is 50,000. It is integer division, no problem. So what is value of S1? Equal to S2 star S3 / that is divided by S4. Now if I print S1, now you can see here it comes out to be negative number. Why? Because S2 multiplied by S3, it goes beyond this. So MSB becomes 1, it is signed integer, the number becomes negative. It is being represented in 2's complement form. Whereas if the same values, same expression, if I evaluate by first making the result smaller, so divide S2 by S4, logically it is evaluating same expression, S2 divided by S4, so the result becomes smaller, then multiplied by 5000. So here this gives me, with calculator also you can calculate integer division. This gives you the correct value 50,000. Otherwise if you use this expression like this. So I always maintain that use programming language code to solve your problem, but always keep in mind the data limits and precedence of operators. Okay, so I have demonstrated the program. Now in the next video we will learn various branching and decision statements. That is all in this video. Thanks for watching.